The power of the internet. All right, there we are. We are live with a titanic figure in my life and in cosmology and astronomy, Dr. John Mather, Senior Project Scientist of the James Webb Space Telescope, which has been in the news for some reason. We don't know. I mean, maybe it's because John... his chapter in this book, which he doesn't even have a copy of, Into the Impossible. This I'm going to send you right after this interview, John. Forgive me. John, how are you feeling? How are you doing right now?
I'm great, and I'm greatly relieved because now that we've gotten to this point, I'm just beginning to think of all the things that were dangerous along the way.
Yes, everything that could have gone wrong didn't go, or could have gone wrong didn't go wrong, but it still must have been incredibly
And
nerve-wracking.
we've survived everything. And well, I wasn't nervous, but maybe I should have been. Other people were because they were actually taking care of all those things that I should have worried about. And so plenty of people were nervous doing their job. So anyway, we were so
Yeah.
appreciative and so thrilled that it worked perfectly. It is so perfect. It's beyond expectation. It's almost beyond hopes. So the optical quality is brilliant. So we promised diffraction limited quality images at 2 microns wavelength, and it's almost twice as good as that.
And John, just from a human perspective, I believe you started working on this in 1995.
I
Um,
did.
Kobe was still going on back then. How did this work for you? What was this career step like for you? How did you have the courage to do this? And what does it mean after almost 30 years?
Oh my goodness. Well, Kobe was just finishing. We launched the Kobe in 1989, and we ran it for 4 years. So um, I was more or less finished with my part by 1995, and I'm thinking what to do next. And I was surprised. I got a phone call from NASA headquarters. Would you like to work on this new mission? We're starting a study. And I thought, absolutely, this is the coolest thing I've ever heard of. I want to work on this. And I still think it's the coolest thing.
And that's saying a lot because Kobe changed my life because it happened right when I was starting graduate school back at
I
Brown, and
see.
yeah,
Yeah, it certainly did.
and it changed your life too. Eventually, you would win a Nobel Prize with George Smoot for that work. Did you have? I know, like those of us that have children are blessed to have children. Those of us that are blessed to have more than one child, we always say when they ask us. I used to ask my mom. You know, there are four of us brothers. I said, Mom, who's your favorite kid? She'd say, that's like asking me to choose my favorite arm. And I'd say, Mom, you're right. You're left-handed. You're left-handed, Mom. Come on. Uh, of all the stuff that Webb can do you have a favorite?
Well, I think taking pretty pictures is my emotional favorite. So, what's the science behind that? Well, the first objects that grew out of the Big Bang material, that's the continuation of my fascination with the history of the universe. Something's out there that we didn't expect. I think so. So, just recently, we're just getting a hint from theoretical predictions about how the first gigantic black holes might have grown. It's one of those top mysteries of science. We detected the dark matter effects, we detected the effects of dark energy, and we still do not know what made the giant black holes grow. We know little ones can grow from stars that blow up, but we can't really figure out how the big ones got there. And since there's a big one in the middle of every galaxy, that's a disaster for comprehension. We got to deal with this. So we got predictions, of course, but now we have to get pictures and data. And so that's one of our top challenges.
Yeah, yeah, indeed. So I was able to take some questions from my audience of over 100,000 people that are part of this project that I call Into the Impossible. It's your second time on the podcast, and I'm so grateful that you took this time during this week. We only have about 20 minutes before your next series of meetings, but I wanted to maybe start off with just a personal question, not a personal, a question from me. When we look at the results and the impact they're having on society as a whole, to what do you attribute this fascination? Is it the pretty picture phenomenon, or is it really the public has gotten accustomed to these fantastic not only images but the data from things like Hubble and things like all the other great NASA projects and ground-based projects too? What do you attribute the fascination of the public? This is so arcane and it took so long. Why is the public so interested in this?
I I think they're interested in the same question I'm interested in. Where did we come from? What's the history? How did we go from an expanding universe with the hot and cold spots in it that we measured with the COBE to here we are having our little planet that's a nice place to live? How did that happen? And there's so many steps that astronomers can work on. The formation of the stars and the galaxies and the black holes and all that stuff. How did the planets grow? Of course, we want to know. And we also really want to know, are we alone? Everybody wants to know that. My personal opinion is, no, we're not alone, but the neighbors are really far away. In other words, a good planet is hard to find. And even though we know most stars have planets, quite a few, we have not found any systems that resemble our own solar system yet, which is to say 3 or 4 little rocky planets in the middle, then 4 or so big cold gas giants way out there. We don't have anything like that to point at in what we've found so far. So what's going on? Our solar system might be special. So we know Earth is already special here in the solar system. It's the only place where we can live. And so what's going on? How come? There's a lot of mystery here. And of course, we all want to know, is there life on Mars? And we can find out by going there and getting some pieces and bringing them back. How about other places in the solar system that are maybe possible, like Europa, where there's an ocean under the ice? Or how about on Titan, where there's lakes and rivers of methane and ethane? Stuff could be happening that we could find by actually bringing pieces home. And that would be maybe even more exciting than our beautiful pictures.
Yeah, exactly. And actually that dovetails nicely with the first question that I received from one of my listeners. And just a reminder, on my YouTube channel, Dr. Brian Keating, you can submit questions for almost all my guests. I always give a preview of who's coming up next. And I had on maybe not so near neighbor to you as well, nearer than those aliens that you talked about, John. And that was Bill Phillips of NIST in Gaithersburg. He was on recently. I solicited questions. His episode's coming soon. But the first question does involve planets. And it's from April Van Ryan. And she asks, my main question is, does Webb have the potential to see a small rocky planet close to us? And what is Miri likely to see when she's used to her maximum potential? I have a billion questions, but those are the first one. So I guess it's about Miri and about the small rocky planets. The WASP 96b, which you did release a spectrum of this week, your team, is a gas giant, not unlike Jupiter as I understand it. But can you see a small rocky planet like the distance from the Earth to the Sun?
We can see them indirectly. We see them when they go in front of their star. It's called transiting. Here in the solar system, we watched Venus do a transit across the sun a little while back, and the sun got extremely tiny bit fainter for a little while because some sunlight was blocked. We do the same thing with little planets way out there. We will have several dozen planets in the first year, including about 24 little ones. But unfortunately for us, the only ones we can study are the ones that orbit very small stars, M stars they're called. And so the planets are very close, and it's a pretty hostile place for a planet. So we'll study them. Some people think they will surely have atmospheres. Other people think surely they will not. So we will be trying that experiment as soon as possible. In fact, I'm not sure when the first ones come up in the schedule, but it's pretty soon.
Right.
So we'll try that. So the other thing she was asking was about the MIRI, which is the mid-infrared instrument, and we will be using it for this transit spectroscopy study also. None of our instruments are capable of seeing a little Earth orbiting a sun-like star. It's just too faint. But we do have pretty good performance for our coronagraphs, which enable us to see brighter planets orbiting their stars. So we are going to be trying that. We're obviously going to try the obvious cases. What about Alpha Centauri? What about Proxima Centauri? We will look. Plenty of people think we won't see anything, but of course we have to look.
Yes, that's right. It's the Wayne Gretzky principle. You miss all the shots you don't take.
Absolutely.
But there's so many, and the resolution's so phenomenal. But I want to go a little bit further out. One of my listeners, or viewers rather, Jimmy Jazzy, asked the question, can Webb rule out or comment on the uniformity of the universe? Exactly, he's referring to the cosmological principle. There's been some claims recently by groups in Europe and other places that you can actually potentially have questions about how much the CMB dipole and the distribution of quasars and other galaxies align with that or don't. What about going to cosmology in a survey sense? Is Webb equipped or positioned in any way to look at things and see, potentially to comment on whether or not the cosmological principle might have some need of an update?
Good question. We, of course, did not set out with that as a major objective. We just said we will study everything you can see with an infrared telescope because it's all new. We got the pioneering observations with the Spitzer telescope. If you want to answer questions about is every place in the sky basically the same, you need to study a lot of sky. So the next big telescope going up for that purpose will be Euclid from Europe. And then the next one after that is ours from NASA. It's called Nancy Grace Roman Space Telescope. It's a 2.4 meter diameter, same as Hubble, but takes 100 times as much sky at one bite. So it will be really good at surveying to look for those cosmological questions. Is every place really the same, or is there some funny business going on about the expansion? So too soon to answer your question, but...
Yes. So another listener is asking, a viewer, HC Traveler is asking, when will the Trappist1 system, or will the Trappist1 system be viewed by Webb?
I think we're starting right away because it's an obvious candidate. I do not remember for sure when the first observations will be. You know, we cannot see every target all year, but I think I heard that this one's coming up soon.
So how does the prioritization work? Again, you know, thinking back to children, and, you know, we scientists are kind of like children. You know, we're curious, we're imaginative, but, you know, we don't play well with others. We don't like to share our toys with how do you prioritize? You know, I mean, among all these phenomenal science goals that you have equipment to look at, how do you prioritize? Today we're going to look at this, tomorrow we're going to look at that.
Okay, well, of course, we do it with committees. So that's the natural thing for astronomers. You have to send us a proposal, Brian. If you want to observe something with a telescope, you have to write it down, send us in for a discussion. And you have to prove that this is a good idea and that you know what to do with the data when we give it to you. And by the way, you are supposed to tell us everything about the concept, but you're not supposed to tell us who you are. We want to review this without knowing whether you're, I don't know. We just want to be fair as much as possible. So one curious result of that is that about 10% of the proposals we chose were submitted by graduate students. So this is really great for young people to get in. We welcome that. And it's a lovely surprise that so many young people have succeeded by writing the best proposals. And of course, if you choose which organizations are going to get the picture, then you say, now, what time of year are we going to observe it? And so that's governed by a calendar. When are they in the line of sight? When can the telescope point at that target?
How long will Webb last in an optimistic scenario? How many years?
We are expecting at least 20. We were requiring 10 or even 5, but we got a really good launch, a basically perfect launch from the Ariane 5. And so we didn't have to use any extra fuel for compensating for its errors. And now it turns out we're not even using up fuel as fast as we thought we would. So maybe even more than 20 years is possible. So if you've just been born, you might still have a chance to use this telescope.
That's right. So some of our graduate students, hopefully will be working on this, our grand students. WD asked a question. Thanks you for your great service, giving us eyes we've never had before. My question is, now that JWST is a reality, are there any projects on the horizon that not only will self-assemble the way that the Webb did, but maybe self-replicate? Could you see a telescope factory in L2 the way that Webb is, but making other telescopes for the future? Is that even a conceivable possibility?
Well, people like to speculate about that, and we draw sketches of how we would do it. But so far, it looks kind of fanciful because we haven't gotten to the first steps. Everything we've done in space required astronauts to put it together. Um, so Webb is sort of the most elaborate self-assembling thing we've done for astronomy, and it was pretty scary
Yeah.
because when you put it together, you say, "What if it doesn't work? Oh my gosh, what do we do then?" And that is so well. When we started, it was impossible. Now it is possible to get a rocket out there with help, but so we do design our next missions with this in mind: the possibility of sending help,
Yeah.
either robotic or human. But at least Webb was done without that possibility, and that's
Right.
pretty scary.
Yep. As you took the advice, you went into the impossible. You did the impossible. Missy Carr is a good friend. She's saying, "This is so great. Thank you. You're the coolest thing." The question is now about in our solar system. What can it do with regard to, say, Europa? Can we look at Europa, and where's most of the exoplanet science going to come from with Webb? Is it images or spectrum?
Oh, okay. Well, first Europa, we will be watching Europa because it's got an ocean with ice over it, and there are cracks in the ice where water comes spitting out, and we discovered that with Hubble. We will be looking at those same places with the Webb to see can we see it with infrared signals, and I don't know. We will try it. And why would we care? Well, you'll learn something with Webb, but we're also planning to send a mission out there to fly through those plumes of water and see do they have other molecules in them, like organic molecules. And I don't know whether they do or not, but personally, my guess is that ocean could be alive. Why not? And in that case, look for complicated molecules. So we'll do that. So the other question was more about what are we going to observe about exoplanets. And so we'll be working on the easy ones and the hard ones. The easy ones are the big ones, like the one we already showed, where it's a big planet and obscures quite a lot of the starlight, and we already know that it's got water in it. But when we say water, we really mean steam, because that planet. It's right in there close by to its star. And so we will be looking at a wide variety of these things, some hot and some cold, some big and some small, because we just do not really know where to look. We should look at everything.
Mm-hmm.
Don't just look where it's easy, look where it's hard. Don't assume you know the answer of what the right place to look is. As you know, everything about exoplanets was a big surprise. When Mayor and Kalos looked at their data to see if there was a planet there, they didn't expect it. Other people had taken data and they hadn't even looked at the data to see if there was a planet in there, because, of course, who wants one of those? We want Earth. Well, there wasn't any Earth in that system, but there were these other remarkable surprises, and everything's been a surprise. So I don't know what the next big surprise will be. Maybe it'll be all those little rocky planets have atmospheres. Maybe it'll be that none of them do. And too bad. No, you can't do chemistry on nothing. So go build the next telescope. That's what that'll tell us.
Yeah, there are questions about that too. Maybe just when we look out at the current data, it's just astonishing to think that you started working on this project in '95, and that's when the first exoplanets were really coming to the light of reality. And so that wasn't, as I remember, that wasn't really part of the original mission design, I mean, of Webb, but it kind of has become this almost unique niche that Webb can accomplish. I wonder, John, can you talk a little bit about the partnership between experimentalists like you, and observers, but also with theorists? A question is coming in about that. Is there what kind of tight knit partnership? I remember on Kobe, from an outsider's perspective, you benefited tremendously from the involvement of theorists. How does that work with Webb? Is there still an opportunity for theoretical contributions, or is it basically they're going to look at the data and like everybody else? How does that work?
Okay, well, it's sort of a lot of different phases of a project. When an instrumenter like me says, well, I've got an idea. Oh, that's cool. That's just an idea. Well, why would you want to do that? And then you have to say, if you could do it, what would you find?
Yeah.
What might you find? What are the mysteries that you would really address? So for that, we need imagination. We need the people who have already done the work of observing, and they say, well, I can't see far enough. Or the people who do the calculations see, I imagine that this could be, but how can you tell? So we can't get the resources to build that equipment unless you tell us to.
Hmm.
So that's at the beginning. Then after we do get along the ways, then suddenly theorists say, I better predict what they're going to see before they see it, so I can get my credit for my proper kind of imagination. And that happened with the Kobe satellite. When we started, there was no prediction anybody could believe. By the time we launched, there were some really good predictions, and some people got it right, what we would see. Other people were completely amazed. They thought, oh, that can't be right. So when we published the map of the anisotropy with the hot and cold spots, there were a few people that had a pre-written scientific paper that was only waiting for the information to come from our data release, and in a day they had it submitted. So we expect some of that for the Webb as well. We told people what data we would take, and they will be ready to plug it into their papers and say, here we are. We know what that means.
So, John, I know you only have about 5 minutes left. I want to be so respectful of your time. We have so many questions. People are just so delighted that you're taking your time, and you've always been a public servant in such a wonderful way, both as an inspiration to young scientists, like when I was young. I'm not young anymore, but my current students, but also to the public. You do such incredible outreach. I want to commend you for that, because not all scientists do that. I always make fun of science. I say you have a moral obligation to do outreach to my fellow colleagues. I want to do kind of rapid fire, just because there's so many questions that are coming in. Andy Oates, who's a very good friend of the show, he asks, is there a chance that the first definitive detection of an exomoon could come from JWST?
Oh, I would love it, but I don't expect it.
Okay.
I don't know how you do it. I know theoretical predictions have been made, but I don't think anyone predicts that we could be able to do it. This is really, really hard.
Yeah. And some claim it's important to the establishment of life that we had the moon to block, asteroid impacts and so forth. So who knows? It may keep the neighbors even farther away from us. Gunnar McStabby, which is kind of a scary name, he asks, are there models of what look like SMACS, what the SMACS cluster would look like in previous years versus today? Is there any way to do a differential between these very distant galaxies and see how many more galaxies is the universe producing more galaxies that we could see from the Webb data that you have?
Okay, well, I don't know about that specific place, but we do have movies that are made by supercomputers.
Oh, really?
You say, I know how the universe started. I've got the hot and cold spots. I know gravity works this way. Start the computer running and simulate everything. And you can get beautiful movies of how the galaxies grow. And we have gotten pretty far with that project. Not only can you make movies about how the galaxy stuff would grow, but you can even now make simulated Webb telescope images. Since the Webb telescope image is not a movie, it's a sort of snapshot of pieces of the universe at all different times from now all the way back as far as you can go into the distant past. So superposition of movies of different places, all seen in one picture. So we can do that now. And someday somebody will be able to answer this question well, but not today.
So a question coming in again from Ollie Wright, who's a good friend. This bears more on the guest who's chapter 1 in this book, and that is our good friend Adam Rees. So you'll get your copy. I'm going to send this out immediately. You're chapter 8, but Adam is very interested in the Hubble tension. So Ollie's asking, are there observations planned that will weigh in on the so-called Hubble tension from Webb?
Absolutely, it's a top priority, and Adam, of course, has proposal in. I'm not sure when it's scheduled. It's a hard project. Because what you have to do is survey the universe even more accurately than we've done before. So Webb has the capability in principle to do this, but it requires so many steps. This is a curious situation where we use the brightness of objects to determine how far away they are, but now you have to establish that you know how bright they really are. And so this is a pretty tricky problem. So anyway, Adam's working on it, and so his competitors.
Yes,
so
exactly.
We will see what they get. And the way things usually go is we do not resolve the tension. We just get more and more sure that we're right and the other person is wrong. But eventually we'll find out.
So in the last minute that you have, John, there's a question. Do you have advice to people in the field just starting out, maybe young graduate students or even undergraduates? Do you have any career advice? We talked about that in the last interview. I'll put a link to John's previous interview and, of course, to the book. as well. But do you have advice to young people just starting out in astronomy?
Yeah, I would say that our field is changing rapidly as new technology comes online. And so you can't really say, I know what I'm going to work on in 10 years because it probably hasn't been invented yet. So um, try to get in on the latest wave of things, and you may catch that wave. And like I've said, graduate students can propose successfully to observe with the Webb telescope. So don't assume you can't do it just because you're young. Just give it a try, see what happens. That's my motto in life. Give it a try and see what happens.
Yes, and so John, I want to thank you. I know it's 10 a.m. out there. You've got another important meeting. Hopefully, we'll come back maybe in a few months when we have more phenomenal data
Sure.
from the James Webb
Yeah.
Telescope. For now, I want to thank you. This is John Mather, who's been a titanic figure in cosmology. You don't see me. There's John. Here's a picture. John, you'll be getting
Yeah.
this book, signed copy, along with some
Thank
other
you,
gifts
Brian.
from yours truly.
And there will be many other investigators to tell you stories about what is found with the Webb.
Love to host
Many
that.
other people that know more about their topic than I can ever know. So they'll be fun for you too.
Thank you so
Thank
much,
you, Brian.
John. It's been such a pleasure.
Okay.
Bye, everybody. Tune in next
Bye-bye.
time. Bye, guys. Thanks, John.